Welcome and thanks for joining us for our second session of the 2021 Landscape Faculty Academy webinar series. You are tuned in for the ASTM Bonders Qualification Certification course. Before we get into our housekeeping notes, I would like to thank our sponsors, Rainbird, Hunter, Ewing, and Brightview for helping make this event possible. A quick moment for housekeeping notes before we get started. Everyone has been muted by default, so we won't be disrupted by latecomers. Please keep your microphone muted throughout the entire presentation unless you have a question, as this will help minimize any background noise. During the presentation, if you have a question, you can ask verbally, raise your hand, or via the chat box. I will be monitoring the chat box throughout the entire presentation, so if you have any questions or can't see anything, I will be reading those and relaying them to our speaker. Without further ado, please welcome Stephen Gardner.
Thank you. My name's Stephen Gardner. Welcome to all of you. I think some of you I met about 5 years ago in California. Some of you I've never met. So let's go ahead and get started. I'm going to download a PowerPoint. We'll go through the PowerPoint, and during the PowerPoint, if you have any questions whatsoever, please feel free to ask. Okay. So like I said, my name's Stephen Gardner. This is my contact info, cell and email address. I work for IPS Corporation. IPS makes the Weld-On and Chrissy's solvent cements, primers, and accessories. In this past year, we introduced our Eco Series. Okay, it's an ultra low VOC product line that maintains the same superior joint strength as our other solvent cements, but at a 30% lower emission of solvents. That means it's less odorous, it doesn't smell as bad, and that improves your working environment. In 2023, South Coast Air Quality Management District, the southern counties in California, are restricting the emission allowed, and these products meet that 2023 requirement today. What we're covering today are the solvent welding process, which is the basic principles of solvent welding, the proper techniques of solvent welding plastic joints, the importance of using the correct size applicator. We've all seen quart cans, they have the Dauber on the lid. That Dauber might not be the right size applicator for the job you're actually working on. So we'll go over how to determine that. We'll also cover set and cure times, tips for hot and cold weather installation, and causes of failed joints. Now, you can't understand what a failed joint is unless you understand what a well-made joint is. These cans of solvent cement, what do you guys call it? You might want to unmute yourself if you want to answer. What do you call the cans? You say grab a can of what?
Solvent cement.
Yeah, or most people call it glue, right?
Right.
You know, right? There's no glue, there's no Elmer's, there's no dead horses. We're not sticking these joints together. We're actually solvent welding it. Just like metal welders weld metal by heating the metal and melting it, we're melting the plastic using chemicals or solvents. Okay, so when you apply the primer, you feel it drag. That dragging sensation you feel is the solvent softening the plastic. Okay, the pipe is a cylinder, and you're trying to put it into a fitting socket. That fitting socket looks straight, but it's actually tapered. It's a cone. You're trying to put a cylinder in a cone. You're not going to get to the bottom. You're going to hit the tapered side before you get to the bottom. So how do you get it to the stop? You're going to apply that solvent. Its only job is to soften that plastic surface. So now that it's soft, it allows you to bend that taper to get to the stop. So where it hit that taper, that's known as an interference fit. The tighter that interference fit, the more fusion area you'll have inside your joint. So it's going to hit higher, and that gives you more area of fusion. Because where you hit that interference fit down to the stop, that whole area, usually it's about the bottom third of the joint, is going to be fused. And that's going to account for approximately 85% of your joint strength. And what happens is, where you bend that taper at a molecular level, when you feel a drag, it's also activating the molecules and allowing the pipe and fitting molecules to intermingle. So as it dries during the cure time, they fuse together and become one piece of plastic. And your joint becomes the strongest part of the whole system, because now instead of two pieces of plastic, you have one piece twice as thick, okay? And if you did it right, it will last the life of the system and be fully functional. Now, what causes failures? Well, 99.9% of the time, it's installer error, not paying attention to workmanship. Pipe's not cut straight. The pipe end isn't beveled or chamfered. The pipe end isn't bottomed out into the fitting socket. Or it did get bottomed out, but you didn't hold it long enough and it pushed out some. Okay, you put too much primer or cement. If it puddles in that puddle is solvent, it's still softening that plastic. Okay, you got to work that primer in until you feel it drag. I don't know how many failed joints I open up, I see purple primer. I can read all the pipe markings. Well, all those pipe markings should have dissolved, disappeared. Number one cause of failure, though, is not enough solvent cement. And the reason is inertia and the way your wristing works with gravity. When you're applying the primer and cement on the pipe end, you're going to lose contact on the bottom. You're going to have nothing here. You'll have a U shape with primer and cement at the bottom and nothing up above. Rotate the pipe. Make sure you have an even coat all the way around the circumference of the pipe end. If you can't rotate the pipe, bring your elbow parallel to the pipe, and that will maintain contact of the dauber head or swab head, whatever applicator you're using. Okay. Now those solvents, I said their only job is to soften that plastic surface. They do that job well, but there's one bad side effect. They're highly flammable. So we'll cover safety precautions also. Now we've been making these products for over 65 years. Like I said earlier, all our products are low VOC. VOC, volatile organic compounds, sound complicated. Like I mentioned earlier, it's just an emission into the air of the solvent. That South Coast Air Quality Management District I mentioned, they're the ones that regulate what is a low VOC product, and their regulations were adopted by LEED for the sustainability codes. So a lot of you or your customers or the people you train have worked LEED projects. Under the LEED standard, our primer and cement gets an automatic credit towards LEED for the air quality because it's a low VOC product. The pipe, the fittings, they don't. You got to prove that they're sustainable in their application before you get credit. Now, NSF says our cement and primers are safe for drinking water, UPC, Uniform Plumbing Code, and up in Canada, CSA, Canadian Standard Association. Okay. Here in the US, we follow ASTM standards. So pipe is extruded, goes heat, air down an extrusion line. When they're done, they check the specs, make sure it meets the ASTM standard. Likewise, fittings. They're injection molded through 12-inch. It's all heat. So when they're done, they're glossier than the pipe. They have a harder surface tension than the pipe. And they check those specs to make sure it meets ASTM standard. Now, the ASTM standard for fittings, there's a minimum socket depth, but there is no maximum socket depth. That means you can get the same type of fittings from different manufacturers, and they may have different socket depths. So that requires us to take a tape measure, measure the socket depth from the stop to the entrance, and mark that on the piece of pipe that's actually going into that fitting socket. So we know exactly where that socket depth is. And you're going to put a second mark 1 inch further down the pipe, okay? And that's going to be your insurance mark to make sure you bottomed it out. And we'll get into that later. Okay, ASTM standards are also for primer and cement. So before we put it in cans, we make sure we meet those standards. And what I'm training you today is an ASTM standard practice, ASTM D2855, which is the national standard practice for solvent cement welding, PVC and CPVC pipe and fittings. So the purpose of this class is to minimize your leaks and failures so you can maximize your productivity and profitability. All companies are in business to make money. They cost out their jobs so they know what profit they should make. But if you have to rework a joint, you're losing money. Minimum 3 times the original cost. The cost of doing it wrong, the cost of cutting it out, and the cost of doing it right. Cost accountants and owners will say no 10 times because of lost opportunity costs where that crew could have been working on another job making more money. Okay, so the purpose is to learn it, how to do it right the first time, every time, so you minimize those leaks and failures and maximize productivity and profitability. Cement has different viscosities. All viscosity means is how thick the cement is. We talked about that tapered side inside the fitting socket. Well, on small diameters, it's a tight tolerance, not much space. But as you get to bigger pipe, they're allowed more tolerance, so you get a bigger gap between the pipe and the fitting. You need a thicker cement to fill that larger gap. So the regular bodied cement will do 1/4 inch through 3 inch diameter piping. Medium bodied cement will do 3 through 6 inch diameter piping. Heavy body, 6 through 12 inch diameter piping. An extra heavy body for everything above 12 inch in diameter. The primer will soften the surfaces faster than cement alone. Okay, it's good on hard surfaces, Schedule 80 and CPVC. Comes in both clear and purple. Performance-wise, they work the same. The only reason we make a purple primer is to meet code, make those inspectors happy. Everybody else upset when you spill it. If you spill the purple primer, wipe it up immediately, pour clear primer over it, scrub as hard as you can, wipe it up. If it's still stained, take that orange hand pumice cleaner, pour that on, scrub harder, wipe that up. If it's still stained on concrete, cement, you're probably going to have to sandblast and refinish. Okay, on the bottom of the cans will be 2 lines of data. The first line will say low VOC max. This says 550 GL or 550 grams per liter. That's that South Coast Air Quality Management District formulation of what is a low VOC product. 550 grams per liter is for primer. 510 is for PVC cement. 490 is for CPVC cement. You have to remember that? No. Okay, just know it's a low VOC product. Okay, the second line is our batch date. That's the date of manufacture, when that can was filled. So if it says JUN/21/A, that means that can was filled in June of 2021, A being the first batch of the month. If it had a Z, it'd be the 26th batch of the month. PVC ABS cements, primers, and cleaners have a 3-year shelf life. They're good through the end of June 2024. CPVC cement doesn't last as long, only 2 years. It would be good through the end of June 2023. That's true as long as they're in tightly sealed containers. So as soon as you open these cans up, all bets are off. I don't know what you're doing with it. You leave them open on a hot summer day, leave it out in the parking lot, come back, both cans are empty. Your cement can has a ball of plastic on the Dauber. That was the resin, okay? Or you didn't seal the can properly. You come back and reopen it and it's gelled or stringy. Get rid of it, okay? Your primer, cement, and applicators will account for less than 1% of your project costs. Your labor is a whole lot more. The pipe fittings are a whole lot more. Pumps, valves, all that type of stuff is a whole lot more than the primer, cement, and applicator. But if you don't use the right product and put it and assemble it correctly, you can get very expensive very quickly. I had one guy fail a 6-inch CPVC elbow, ended up costing them $11 million because of the damage it caused. So make sure you got good product and you know how to do it properly. Now, cans this year, they got rid of this low VOC line. They still have the batch date, but they added the expiration date, so you don't have to sit there and try to remember which of these is which. It will be on the can now. So as I mentioned before, ASTM D2855 is the national standard practice for solvent cement welding, PVC and CPVC. There are 4 basic principles. 1, the joining surfaces must be softened and made semi-fluid. What's doing the majority of that work? Primer or solvent cement? Anybody?
Primer.
Primer. It's the first thing that hits the surface. It's going to do the majority of the work. Cement also has solvents in it. It will continue that process. 2, sufficient cement must be applied to fill that gap between the pipe and the fitting. Well, what did I say was the #1 cause of failure?
Not enough cement.
They didn't follow the second principle, didn't put enough cement in there to fill that gap. 3, assembly of the pipe and fitting must be made while surfaces are still wet and cement's still fluid. It's a chemical weld, okay? So these chemicals have to be wet to work. So while the primer is wet, you put the cement on. While the cement's wet, you put the joint together. If the primer dries before you get cement on, you can re-wet it. But cement's a one-shot deal. If the cement dries before you put it together, you're gonna have to cut it out and start over. Unfortunately, solvent cement welding is a very simple process, but it's an unforgiving process. If you do it wrong, there's only one option. Cut it out and do it right. Okay, you don't get mulligans, can't do it over. You gotta start all over. And then 4, joint strength develops as solvents escape. So this first X is where that interference bit was, where you first hit the taper. You've softened the sides, you're able to bend it to get to the stop. Okay. From that interference bit to the stop, to the bottom of that fitting, that's where the fusion takes place. About 85% joint strength's there. Above that, you're filling the gap between the pipe and the fitting where that taper goes away with the fitting from the pipe. And that's going to be bonded surface. So if you don't cut this pipe straight, you don't bottom it out. We did bottom out and it pushed out some. All those circumstances, you're losing fusion area. It won't hold pressure over time. Likewise, if you don't bevel this pipe, the standard says that bevel should be a minimum width of 3/32 of an inch with a 10 to 22 degree chamfer. I tell people, nobody's ever going to measure it. Just knock the edge off. It allows you to enter that socket entrance cleanly, get all the way to the stop to maximize your fusion without scraping all that primer and cement. You just worked hard to get in that joint. Okay. If you don't chamfer, bevel that pipe, the edge is going to be sharp and it's going to work like a plow and just scrape out all the cement and primer. Okay. This is what a dissected solvent welded joint looks like. Top here is where it's fused together. Bottom is darker, there's more cement there filling that gap between the pipe and fitting. That's going to be your bonded area. The line dividing those two, okay, that's where the interference bit was. So the tighter that interference bit, the more fusion. The looser that is, the less fusion there will be. And you notice there's cement on all the surface area. So applicators. 3-inch diameter piping and smaller, you want to use a Dauber. The Dauber head should be approximately 1/2 the diameter of the pipe. Another way to think about it is double that Dauber head size should equal diameter of the pipe. If you're going to use the can lid dauber, you don't want to hold the lid. That stem will just snap off. Hold the stem, not like the guy in the photo. Hold the stem. That allows you to apply it aggressively enough to feel that dragging sensation without the stem bending or snapping. Okay. We also have our super dauber. It's made of hard plastic so that stem doesn't break. A longer handle so you can more aggressively apply it to the pipe and fitting. Different size dauber heads to meet different diameters. The top here is tapered like a cork for a wine bottle, so when you put it in the can, the solvents don't evaporate. And when the can gets low on product, instead of tilting the can sideways, you can extend this stem out. It telescopes out so you can get to the bottom of the can. Okay. For bigger pipe, 4-inch diameter and larger, you want to use our super swab. It will fit both a quart can lid and a wide mouth gallon lid. In a quart position, it will do 4 to 8-inch diameter piping, and you can extend this down for a gallon can. Now it will do 6 through 30-inch diameter piping. When that swab is worn out, throw it away. Keep the stem, keep the handle, load in a replacement swab. You're good to go. Okay. The can tote here, I show you just to remind you that these can labels have to be legible. These are chemicals. So under OSHA requirements, you have to be able to read them. So if you keep reusing the same can and it gets covered with cement or primer, you can't read that label, that's a problem. If you duct tape these together and can't read the label, that's a problem that OSHA could give you a fine for. Okay, material prep. You need to cut the pipe straight, 90-degree angle, square. How you cut it, I honestly don't care. Chop saw, bandsaw work great. Wheel cutting tool for the smaller diameters works good. Whatever you're using, the blades have to be made for plastic piping and be sharp. If they start to dull, replace them. One cutting tool I do not recommend are ratchet cutters. They tend to crush the pipe, not cut straight, and below 50 degrees Fahrenheit tend to crack the end of the pipe. So once you have this pipe cut straight, you need to remove the burrs, raised beads from the end of the pipe. A knife will work, definitely not the safest. This file will work, definitely not the quickest. We recommend you use deburring tools. This is a cone beveling tool, works good, okay, occasionally chatters. These two are made by Reed Tool Company. This is known as a DEB1, DEB-1. DEB short for deburring tool, okay? It'll do 1/4 inch through 1 inch diameter piping. This is a DEB4, DEB-4. It'll do 1 1/4 through 4-inch pipe. This gentleman here in the photo is using it. All you got to do is go around once or twice, you're done in seconds. Then you need to clean the end of the pipe and inside the fitting socket with dry clean cloth. If it doesn't get clean with dry clean cloth, use our C65 cleaner. Just remember that cleaner just cleans the surface, doesn't soften it. Let it dry, wipe it dry, and then apply your primer and cement. The dry fit is what I mentioned before. You're going to slide that pipe in until you feel it hit that taper. Okay, that's your interference fit. It should only go in about 1/3, 2/3 of the way. Okay. Now you're going to mark the pipe. You're going to have your socket depth mark, and then that second mark 1 inch further down the pipe. If it's smaller pipe, if you're dealing with bigger pipe, 4-inch or larger, I might move it to 2 inches so I don't get it covered with primer and cement. When you apply the primer, that first mark is going to disappear along with any other pipe markings on the pipe. I go about 1/2 inch past the first mark with primer and then leave about 1/4 inch of primer showing when I put on the cement. That way, if I have an inspector behind me, he sees 1/4 inch of cement and 1/4 inch of primer and he knows it's good. Okay, there's no questions there. This second mark, when I'm done, I'm going to measure from the socket entrance to the second mark should equal 1 or 2 inches. That tells me I'm bottomed out. If it's greater than that, then it means I didn't bottom it out. I got to cut it out and start all over. And again, don't hold the lid, hold the stem. Okay. Now applying primer and cement. We're going to start with primer. So we soften the surface. We're going to start with the fitting because it's a harder surface, okay, because of that glossier finish. So we're going to put a full coat of primer inside the fitting socket, okay, and work it in till I get complete coverage and I start feeling it drag. I tilt this fitting down, so if I have any excess primer, it drains out of that fitting. I don't want it puddling on the other side of the fitting. And then while the primer is wet, I'm going to apply it to the pipe end. I want a full even coat all the way around that circumference of the pipe end. So again, rotate that pipe. Make sure you got an even coat all the way around. You will notice you may have a lower level on the back side where you lost contact. So rotate that pipe. Make sure you got good coverage. Once you have it complete coverage, about a ½ inch past that first mark, and you feel it drag, redip. We're going to do the fitting socket a second time. Why? It's harder. But the second coat's going to be a whole lot quicker than the first. You're going to get coverage quickly, and it should start feeling like it's dragging almost immediately. Again, tilt it down, let any excess primer out. Don't let it puddle on the other side. And while the primer's wet, now I'm going to put a full coat of cement on the end of the pipe. Again, just like the primer, I want to make sure I got an even coat all the way around that circumference. Rotate that pipe or keep your elbow up, keep it parallel to the pipe so that dauber head, okay, maintains contact. And then once you have full coverage, you're going to go directly to the fitting. Do not redip, just go directly to the fitting and put a complete but thin coat of cement inside that fitting socket. And then redip and put a second full coat of cement on the pipe. Why? Number one cause of failure is lack of cement. Technically, you can't put too much cement on the pipe end because any excess is going to come out the entrance. Okay? But you guys are professionals. You know how much to put on so you get a nice even bead around. Okay? And it looks professional. Okay? Now, common sense here. If I'm working on 6-inch pipe and larger, I'm probably going to have to redip just to get coverage on this fitting socket. But I want a thinner coat. And conversely, if I'm dealing with 1-inch pipe or smaller, I might not need this second coat because I'm more worried about puddling. So use your common sense on the bigger pipe and on the very small pipe. And then while the cement's wet, you're going to assemble it. Insert, quarter turn as you're inserting, push the stop and hold. Okay. Now, as you get to bigger pipe, that quarter turn might not be possible. So you got to make sure you got a complete coverage on here, because the only purpose of that quarter turn is equally distribute cement, cover up any errors you may have had. Okay. But the quarter turn is not needed technically if you have a full coat all the way around the circumference of that pipe. Okay, so when you get to a 6-inch pipe and bigger, you're probably not going to twist. You're just going to insert, push the stop, and say a prayer you bottomed it out. You want to hold it approximately 30 seconds. Now, that's a rough ballpark. If I'm doing ½ inch pipe, it might be 10 seconds on a hot summer day. If I'm doing 20-inch pipe and it's cold, 20 degrees out, it might be 20 minutes. So if I'm doing 6-inch and larger, I strongly recommend you use some sort of mechanical assist device to help push that in to the joint and hold it in place. Okay, like a pipe pulling tool. Okay. Now, while you're holding it, you want to inspect the complete circumference of that socket entrance. There should be a bead of cement all the way around. If there's a void with no bead, it means you probably don't have enough cement in that joint. You won't have fusion. Cut it out and start over. Now, let's say I got a bead all the way around. That's evidence I got enough cement. I have fusion. Do I want to leave the bead there or remove the bead? Anybody?
Leave it there.
Leave it.
Everybody say leave it.
Wipe it off.
Wipe it off is the correct answer. 3 reasons why. And then you'll think of common sense and say, gee, I should have thought of that. What's in that bead of cement?
The
Salt.
solvent weld.
Yeah, solvents. What's it
Solvents.
doing to the pipe wall?
Eating away at it.
Yeah. And then number 2, that 4th basic principle, joint strength develops as solvents escape. You just block their escape route. Then 3rd, by default, makes that joint look neater, as long as you're smart enough not to smear it. Okay. Now, set and cure times. Set time impacts every joint you make. Okay. It's the amount of time you got to protect that initial fusion before you manhandle that joint. Now, if you move it around carefully, have it supported in alignment, you don't have to wait set time. You can keep working, but don't manhandle it. Don't bang it. Don't break that initial fusion. Cure time's different. Cure time starts when I finish the last joint in the system and I wipe the bead off. And then it's the amount of time I have to wait before I can do a hydrostatic pressure test. What's hydro mean?
Water.
Water. Always test with water, never with compressed air or gas. 5 psi water and 5 psi compressed air. The pressure is the same. 5 psi is 5 psi. The potential energy behind that pressure is totally different though. Think of a big spring. I can only compress that spring so far with water and it comes back. Air, I can compress all the way and it shoots back like a rifle. Think of the rooms you're in. It's filled with air. Can I compress all the air to the size of my fist? Yeah. Open my fist, it refills the room instantaneously. That room was filled with water, I couldn't compress it to my fist. Okay? So there's a whole lot more potential energy behind the compressed air or gas. And what it's going to do if you test with compressed air or gas and it fails, it's going to cause a catastrophic brittle failure. What that means, it's going to generate sharp shrapnel that will travel 200 yards minimum. If you're between that failure point and that 200-yard radius, you could literally end up as Swiss cheese with holes in you. Give you 3 examples. Pennsylvania, open coal field. Guy tested with compressed air. It failed. Piece of shrapnel went through his hard hat and impaled his brain. He was dead before he hit the ground. British Columbia, Canada. Guy tested with water. But even before you test with water, you got to bleed all the trapped and trained air from the highest elevations of the system before you pressurize it with water. They didn't do that. They had trapped air, it compressed, it failed, hit him in the head, took out his right eye, amputated part of his right ear, and continued another 40 yards into the air after impact. Central part of the continent, okay? Colorado Springs, Colorado. Fab shop ran all their compressed air lines with PVC pipe. It failed over a weekend. Luckily, nobody was in the building. When they came Monday, they all stood out in the parking lot, staring at their building, trying to figure out what happened to the exterior wall of the building. That's where the compressed air lines were. The wall got taken out. So always use water, okay? Now you're gonna need a longer cure time if you're working with thicker cement in cold temperatures, on large size pipe and fitting, or in damp, humid environment. Now, some of you might work like down in the Gulf Coast where it's always damp and humid. You're gonna add 50% to your set and cure times, minimal. I'm more conservative, I just say double it. Likewise, you're gonna need longer cure times for chemical application, okay? That's a safety precaution, so you don't get somebody getting hit by a leaky line that's carrying sulfuric acid or something.
Stephen,
Or,
actually,
yeah,
Actually, this did happen to me. I was November in Nebraska, and I was installing a quick coupler to blow out a system, and I didn't get it flushed with water, and I applied air, and it vaporized the entire system. Fortunately, it was underground in a pit, and I was out of the way.
Yeah, but you could have been killed.
Very easily,
Yeah.
easily. Talking within seconds. I got my head out of the pit just in time.
Yeah, and people, I did this training up in Pittsburgh a few times to building inspectors. They're like, oh, we make them do a 5 PSI air test because the water freezes during the wintertime. I'm like, guys, that's fine. You can test with 5 PSI air. And they're like, you just said not to. Well, the crew's not going to. They're going to the pub. You can go test for them. They get up in the morning. They expect to go home in the same condition they got up in the morning. If you want to put somebody in danger, you put yourselves in danger. They'll bring you back a beer for you. If you're alive, you get your beer. If you're not, they toast you. But you're not going to put their lives in danger. I don't care about your code. That's your business. But when it comes to safety, that's my business. And safety, I don't care what job you're doing. It's the most important thing. Now, you're going to need if you're dealing with higher pressures, you're going to need a longer cure time. And I'll demonstrate that in the cure chart on the next slide. But you're putting together like a 6-inch length of 2-inch schedule 40 pipe and 2 end caps. That will be schedule 80, correct? Everybody got that part of the memo? Nobody? Can you all hear me?
Can you repeat that, Stephen?
Yeah. You'll have a 6-inch length of 2-inch diameter PVC Sched 40 pipe and 2 Schedule 80 2-inch diameter caps to assemble.
Yes, yes.
Okay. Normally on your job sites, you're testing at about 100 PSI. I'm assuming. These will get tested at 750 PSI, a whole lot higher pressure. So we're going to let them cure for 2 weeks. So I'm not testing your cure time. I'm testing your workmanship. Okay. So here are tables for set and cure chart. Okay. Top chart here is set time. The second chart is cure time. And these times are minimums. You got to go at least that long. If you can go longer, better, because it gets stronger the longer you let it sit. Okay. So if I have a 1-inch line, it's 90 degrees out. My set time will be 2 minutes. The cure time, if I want to test at 150 PSI, that 1-inch line, it's still 90 degrees out. I have a 15-minute cure time. Now, I don't know how many people can set up a hydrostatic pressure test that quickly. That's a very short cure time. Now, that 20-inch pipe I mentioned before at 20 degrees, that set time balloons out to 2 days, 48 hours. The cure time for that 20-inch pipe at 100 PSI at 20 degrees Fahrenheit balloons out to 2 weeks, 14 days. 4 things influences cure time. Interference fit. Tighter the interference fit, the less dry time you need. Diameter of the pipe. As you get bigger, you're going to have a larger surface area. That's going to take longer to dry. You're going to use a thicker cement, higher viscosity cement. That's going to take longer to dry. But most importantly, it's temperature. These solvents have an average evaporation point of 40 degrees Fahrenheit. Once you drop below 40, they take a whole lot longer to dry. When you drop to 32 freezing, it expands exponentially. That's why that blew out to 14 days. Okay. Now, do people put large diameter pipe together in cold weather and wait 14 days? No. Here are tips for cold weather. Now, cold weather for solvent cement welding means 40 degrees Fahrenheit. If it gets to 40 or below, then you have to follow these cold weather tips. Store your cement and primer above 40. As long as they're stored above 40, you can install down to 15 below zero. Store your fittings inside until you need it. Pipe is usually stored out at the job site. Put it on a pallet, put a white tarp over it. Pallet keeps it off the cold ground, out of the snow. Tarp keeps snow and frost off the pipe. Take a rag, rub the end of the pipe you're gonna cement. Try to create some friction, heat it up. You wanna try to get your pipe, fitting, primer, cement to relatively same temperature, so you minimize expansion, contraction inside that joint during the cure time. Okay, so on that 20-inch pipe, you're gonna have a 3-person crew. One person applying primer cement to the pipe, the other to the fitting. Third person setting up pipe puller, pouring the primer and cement. You're gonna have 2 pipe pullers. I'm a strong believer in following the 6 P's. Prior preparation prevents piss poor performance. Get everything you need for the job before you start it. Because once you start applying primer, you cannot stop. Okay, you don't have time. Okay, so they're gonna set up that first pipe puller. They're gonna do the first joint. Okay, first coat, they're both putting primer on. Second coat, primer on the fitting, cement on the pipe. Third coat, they're both putting cement on. The guy pouring the cement, when he's done, gets on the pipe puller. Okay, he'll see the 2 guys leave that big joint. Crank down that pipe puller. One guy will wipe the bead, the other one will check the second mark, make sure it's bottomed out. Leave the pipe puller there to protect set time. Take second pipe puller, do the same thing on the second joint. When they're done with the second joint, leave that pipe puller there. It protects that joint and every joint behind it. Therefore, you can take that first puller and leapfrog it to the third joint and continue that process. When they're done, if it's an open-ended system, they'll blow hot air through it. If it's a closed system, they'll put industrial heating blankets over each joint, leaving the socket entrance open so solvents can escape. If they can elevate that temperature to say 65 degrees Fahrenheit, that 14-day cure drops down to 3 days, 72 hours, which is manageable. Now we're getting into heat now. So store your cement and primer below 100 degrees if possible. Keep it in the shade or indoors. Fittings, same thing, in their boxes, in the shade or indoors. Pipe, you're gonna store it the same way you did on the winter time. On the job site, it's usually outside. Put on a pallet, put a white tarp over it. Okay, pallet now keeps it off the wet ground, allows ventilation under there. The tarp keeps dew and rain off the pipe. The white color reflects the sunshine. PVC pipe and fittings have a max temperature rating of 140 degrees Fahrenheit. You leave it in direct sunshine on a hot summer day, it's gonna get well above 140. A nice 20-foot stick of straight PVC pipe will look like a banana because it's out of round from being softened by the sun. Okay, white $20 white tarp would reflect that sunshine, prevent that. Take a damp cool cloth, cool down the pipe and you're gonna cement. Just make sure it's dry before you put primer and cement on. Work in the cool morning hours before it gets too hot. Okay, if you're working on that large size pipe, that 3-person crew is gonna have to work a whole lot faster. That's not just true on the large pipe, it's true on the small pipe too. And not just the heat, but any breeze, wind that can evaporate the solvent. You got to be careful with that too. Okay, you can use a thicker cement, give yourself a little bit more working time, but it's very important to use appropriate size applicator so you don't puddle it. Now, primer just has solvents in it. You don't have to shake those cans. Cement, though, has solvents, resin, and additives. It has to be shaken vigorously before each use. And when you're done with the can, you want to reuse it later. Make sure you clean the top off, the threads on the can, the threads on the lid. Tighten it as tight as you can. The cement can you can flip upside down. The resin's thicker than the solvents. It will fill any gaps on that lid, prevent the solvents from evaporating. Don't do that with primer unless you want purple everywhere. It's water thin, it will leak out. So why do joints fail? didn't follow the basic principles of solvent welding, a lack of understanding. Okay, didn't use proper applicator. Okay, yeah, I got a can of weld on 7-Eleven. The label says that cement's good through 12-inch pipe. Why didn't that can lid Dauber work on 12-inch pipe? It's not the right size applicator. Didn't use proper cement on the piping system. Well, at 7-Eleven, weld on 7-Eleven is a PVC cement. Why didn't it work on CPVC pipe? It's not made aggressively enough to soften that harder pipe material. Or disregarded set and cure times. Okay, if the cure time says 3 hours, I told you that's a minimum. Don't try to test after only 1 hour. All your joints will separate. Okay, interaction time. This is an exaggerated photo. What's wrong in this picture?
Looks like his application is not even.
Not even. What else?
Missing spots.
Yeah, missing spots. What else?
It's a pretty thin coat, looks like.
Yeah,
Yeah.
thin coat. What else?
He's using a paintbrush.
Yeah.
Wrong applicator.
Wrong answer.
Socket depth's probably here. By the time he's putting it up here, it's all dry.
Oh.
What's not underneath the primer? I mean, underneath the cement.
Greg got it.
Yeah,
No primer.
yeah, no primer. What didn't he do to the end of the pipe?
Chamfer it.
Chamfer it. What's not on his hands?
Glove.
Gloves. If you're gonna wear gloves, wear nitro material gloves. It will prevent the solvents from getting to your skin. Now, this photo was an exaggeration to show those errors. These are actual failures. This, they didn't bevel the end of the pipe. It had a sharp edge, scraped the cement down and prevented them from bottoming out. Left side's even worse. They didn't chamfer, they didn't bottom out. There's no fusion here. That's that U shape we talked about. Or not having a bead all the way around the circumference of that socket entrance. That's why I say you gotta cut it out. There's no fusion. That's what it looks like inside the joint. When gray cement gets wet, it turns milky white. That's where the leak was, because there was no fusion. This arrow here above it, it's shiny, glossy. Primer and cement never touched it. Okay. Here you got the opposite. They puddled the primer, they puddled the cement. What's in that puddle?
Solvents.
Yeah, and it's still working at softening that surface. So if I flip that over and look at the exterior wall, that pipe, I'll see lateral stress fractures where the solvents have softened through the wall of the pipe. This was in a trench. It was a high pressure water line that had a leak. Water shut out the leak, hit the earth in the trench. That turbulence cut that erosion hole into the exterior wall of the pipe. Here I got a bead in the upper left, a bead in the bottom right, and a void in between. The red pipe markings I can read going in the socket entrance. They should have cut it out and started over. This is what it looks like from the socket entrance of that earlier photo that showed no fusion. That's because there's no cement there.
Hey, Stephen, what's the
Yeah.
common, what's the most common cause of failure for bell ends when it breaks at the base of kind of at the taper of the bell end? I get a lot of superintendents that'll show me pics of they'll have a break there. What's causing that?
Usually they're using a backhoe to push it together, and the backhoe can't feel it hit, so it keeps pushing.
Is it too much primer or too much cement in there causing a weakness at the base of that
They
taper
might
at the end of the
have.
bell
You
end?
got to be careful when you're doing bell end pipe that the primer and cement doesn't go past the bell, because then it will puddle and might cause that softening and cause that. But in my experience, it's usually caused by too much pressure pushing that pipe into that bell when they initially install it. And that's usually because they're using some sort of bobcat, backhoe, something that it can't feel it hit the stop. But yeah, if they puddle it also past the bell, that could happen also. Especially if you're using like SDR pipe, really thin wall pipe, you have a higher chance of that happening. 'Cause
Oftentimes,
usually-
it may be like SDR 21, oftentimes is what they may use.
yeah, or if they're using foam core piping, something that doesn't have it's not a solid wall like Schedule 40 pressure pipe is or Schedule 80. Okay. Anything else? All right, we have a separate ASTM standard, F402, for the safe handling of these products. Why? They're highly flammable. So I wouldn't recommend eating, drinking, or smoking. No heat, ignition sources, sparks, open flames, anything that can ignite these solvent vapors. These solvent vapors are heavier than air. They're going to settle at the lowest points and stay there. So if you're on a job site with other trades and you're flushing out a line, you might want to consider a job site fire watch so you don't get a metal welder lighting his torch or somebody cutting rebarb that's causing sparks that could ignite these vapors. Okay. Your companies have PPE policy. Okay. If you're on a job site with other companies, there are multiple PPE policies. Follow the most restrictive, that way you're covered by all of them. Try to work in a well-ventilated area. You guys are doing irrigation. Usually that's not an issue, but sometimes you're in a confined or limited ventilated area. You can use an exhaust fan. Just make sure it's explosion proof. Okay, that means the wiring is safe. It's not going to spark, and that will pull the vapors away from you. Or you can always wear a NIOSH approved respirator. All our products come with safety data sheet. All right. True or false? How many of y'all actually read a safety data sheet?
True.
True, you have? Cool. Most people I talk to haven't. How many have read the labels on the cans? True again.
Steven,
I
can
hope.
you see
Yeah.
our cameras at all?
No, I can't.
Oh, okay. Many people are interacting by raising their
Yes.
hands and stuff.
True.
I
Oh,
realize
sorry.
you can't
Oh,
see it.
No, all I see is PowerPoint
Okay.
slide.
Just curious.
True.
All right, perfect.
Yeah. So basically, it's your responsibility to read the SDS and the labels. And on the SDS in section 3, we'll list our solvents because they're flammable. Section 4 will have first aid. Somebody gets it on their skin, it bothers them, wash with warm water soap. Somebody breathes it in, it bothers them, go out to fresh air. Usually those two situations take care of themselves. Everybody's different though. If it persists, get medical attention. Somebody gets it in their eyes, 15-minute water flush of the eyes, get medical attention. Somebody swallows it, give them 1 or 2 glasses of milk or water, try to prevent them from vomiting, get immediate medical attention. Just like any other chemicals, these solvents have to be respected. And like I said earlier, never use our solvent cement and primer products on thermoplastic piping, that's PVC, CPVC, or ABS, when using or testing with compressed air or gas. Always use water. Bleed all the trapped and trained air from the highest elevation to the piping system before you do your hydrostatic pressure test. Serious injury or property damage may result if the system fails and explodes. Any questions? Now I see y'all.
I did have a question on the curing time and the temperatures.
Yep.
Is that the time of application for the wait period, or is it the daily high or low temperature that we're looking at?
You want to use the lowest temperature that will occur during the cure time. So if you do the system during the daytime and it's 50, but it has to cure overnight and it drops down to 30, you're using 30. and the largest section of the piping. So if you got a 2-inch that goes up to a 4-inch, you're going to use the 4-inch. That way you're going by the coldest and largest part of the system. So you maximize the cure time. And if you can go longer past that cure time, that's great, because it's just getting stronger and stronger.
I had a question. Weldon makes the wet and dry
Yeah.
primer. For irrigation, is it better just to use that just in case you have a repair you're doing and there's water seeping back into the system, or
You want the marketing answer or the technically correct answer?
technically correct?
Doesn't matter.
in that?
Physics is physics. Try to keep it as dry as possible. And if it's wet, allow it to cure longer.
Okay.
Because you got to allow for that moisture to cure out. Marketing wise, it's a nice label, but physics says differently. Now, does it have more solvent so it sets quicker? Yes. So, if it's dry enough, you can pressurize it quicker than most, but I still am a conservative person. I'd much rather have it work right than have to redo it again. Anybody else? All right.
I'd ask you this one question, and kind of in regards to the wet solvent welding process. Do you have any tricks or examples on like mainline repairs and stuff that water just keeps
Yeah.
coming out?
Yeah, take a loaf of white bread and cut off the crust, slide that in there. And if you forget to yank it out, it's not going to damage anything. You leave
All right.
a rag in there, you're going to run into problems later.
Perfect.
Yeah,
I have
that's from experience.
One of the things that I've been told about in the past was that you use sandpaper before you prime it. What's your opinion on that?
No,
No, not necessary.
remember I said when you apply the primer, you should feel that dragging sensation.
Okay.
That dragging sensation you're feeling is softening the pipe. That's the same thing you're doing with sandpaper. Why am I going to add an extra step that I got to clean up for?
Okay.
So no, and if I tell most guys you can sandpaper, what are they going to grab? They're not grabbing emery cloth. What are they going to grab?
Yeah, probably.
Grab a grinder. And every time they hit the pipe,
Oh.
there's a leak path. Don't laugh. I've been to industrial job sites where I've seen that on like 6-inch pipe. It's like, gee, we're having leaks. Oh, gee, I cut this open. Every place your grinder hit, you have a leak. So I'd say no, and that keeps people out of trouble. Any other questions? Okay, so I'm going to show you a approximately 10-minute video. Now you're going to have to adapt to it. It's made for my industrial classes, so they're using 4-inch Schedule 80 piping caps. You're dealing with 2-inch pipe, Schedule 40, and 2-inch caps, Schedule 80. Okay, so the process is the same, just it's smaller. Okay, so let me pull that up and show that.
Good morning. My name is Van Hester.
My bad.
Good morning. My name is Van Hester. I'm from IPS Technical Services. This morning we are going to make a ASME B31.3 test coupon. This is the coupon that you will have to make to be certified and to get a card saying that you completed this course. First off, I'm going to put on my PPE. I always recommend wearing safety gloves and safety glasses and gloves. Next, I'm going to bevel my pipe ends. It's very important for the pipe ends to be beveled. If they're not beveled, the sharp edges will just push the cement out of the joint. So it's a very quick operation. I'm using the Reed Dev 4 tool. Go around one time, and it's got a nice bevel. You don't have to pencil sharpen it down, just break the sharp edges. Okay, that's done. Now, what we need everyone to do is mark the ends of the pipe. What I'm going to do, I'm going to measure the depth of these caps. And from the fitting stop to the end of the cap, the face of the cap is 2 1/4 inches. So on my pipe, I'm going to make a mark at 2 1/4 inches. I'm going to make another mark at 4 1/4 inches. That way, when you get the cap placed on the pipe end, you can measure from the end of the cap to this second mark, and it should be 2 inches. Okay, with that being done, we're going to be using our P70 primer and 724 cement today. First off, you need to shake the cement. You shake it well, shake it vigorously. Shake it like you would a can of paint. As you can see, I've taken the Daubers out of the can and I'm replacing with our Super Swab. Anything over a piece of 3-inch pipe, we recommend the use of the Super Swab. Since this is a 4-inch piece of pipe, that's what I'm going to use today. So I've shaken my cement, no need to shake the primer. So I've got everything ready to go. I've got everything laid out just like I want it. Everything's quickly at hand. So now I'm going to start off by priming the cap. And when I say prime the cap, I don't mean just paint the cement on, I mean the primer on. Scrub it in vigorously. 15-20 times around the inside of the cap is not too much. That would be a good number to start with. If the weld is cold, you need to prime it longer. Okay, I'm satisfied that my cap is primed. So now I'm going to prime my pipe in. 15-20 times around. The first thing that should happen, the pipe markings that the pipe manufacturer put on should disappear. And the first mark that you put on is probably going to disappear. So prime my pipe in. Going back, I'm going to prime my cap again. The caps are much harder than the pipe end, or the fittings are much harder than the pipe end. So you have to do more work with the primer on the fitting than you do on the pipe end. So I'm satisfied that this is well primed. Now we're going to put cement on the pipe end. Put cement on the end of the pipe. That is extra bonding area when it hits the fitting stop. Okay, I've got a good round even coating. I'm going to roll my pipe over. Make sure I've got the cement evenly distributed. I'm going to put cement in my cap. Just a medium coating of cement in the cap. Just so it's evenly coated all the way around. You want the majority of your cement on the pipe end. So my cap has got a good even coating of cement. So I'm going back and I'm going to refresh the cement on my pipe end. Okay, I'm satisfied I've got a good amount of cement. I'm going to get my cap started on my pipe end. I'm going to take it to the floor and hold it. Hold all my weight on it for a minimum of 20 seconds. Okay, now. We'll wipe the excess cement off my joint. And now we're ready to do the other end. It's going to be the exact same process. First, we're going to prime my cap again and vigorously scrub the cement in. I cannot emphasize that enough. Do not just paint it on. You need to scrub it in until you feel the swab start to drag. That means the plastic is starting to soften up. Okay, satisfied that my piping is properly primed, all the ink markings have disappeared. Don't want to go back. And I'm going to prime my cap again. Always hold it down so that the excess cement or primer drips out. Do not want it to puddle in the cap. Roll the pipe over, make sure that I've got cement evenly distributed all the way around. Gets off that face there a little bit. I'm going to put a medium layer of cement in my cap again. Now I'm going back to refresh the cement on my piping. Roll it around, see all sides. Make sure that you've got cement all the way around. Okay, I'm satisfied that this is good. Take it to the floor, hold all your weight on it. There. 24. Clean up the joint. It's ready to go. When you're completing the joint, write your name, the date, and the company name on the coupon, and then ship it to us. And it will be tested after 2 weeks your time. It will be tested at 680 PSI for 1 hour. If you successfully complete that test, you will be issued a card saying that you have completed this course. Thank you and have a good day.
Any questions? So when you're 2 inch, you still gotta either put your shoulder over it and push it down, or take it to the floor and push it down so you get it. Because the pressure you're gonna get tested at is 750 PSI. If you don't do that step, you're not gonna pass the test. I guarantee that. Do you have to do that on production joints? No. It's like on your production joints, owners might care what it looks like if it's visible above ground. On these, I don't care what they look like as long as you pass. Okay. Any other questions?
Stephen, I guess my internet cut out when you were talking about marking the depths on the pipe. Can you go through that again?
Sure. Each fitting may have a different socket depth because ASTM doesn't have a has a minimum socket depth, not a maximum. So I might get the same type of fittings from different manufacturers. They have different socket depths. So we take a tape measure, measure from the stop to the entrance, take that measurement and mark it on the end of the pipe that's going into that fitting socket. And then put a second mark on smaller pipe, 3 inches smaller, 1 inch further up the pipe, or if it's bigger pipe, 2 inches further up so it doesn't get covered by cement and primer. The first mark is going to tell you when you slide that in dry, no primer, no cement, you're going to hit the taper. It should only go in about 1/3 to 2/3 of the way. That mark should not enter that socket entrance. That tells you you have an interference fit without looking inside. And then when you apply the primer, you're going to go about 1/2 inch past that first mark. That first mark is going to disappear along with any other pipe marking. Then you put cement on, you leave about 1/4 inch of primer showing. Then as you insert it into the joint, okay, and get it bottomed out, you hold it so it doesn't back out. And when you're done, you wipe the bead off, then take your tape measure again and measure. It should equal 1 or 2 inches, depending where you put it. That tells you you bottomed it out. If it's greater than that, it tells you you didn't bottom it out. You're gonna have to cut it out and start over.
Gotcha.
It's your smaller pipe, you feel it hit the stop usually, but when you get to bigger pipe, you're not gonna feel it. And that's gonna be the only way you know you bottomed it out.
Gotcha.
Or that it didn't push out some. Any other questions?
So on this cap, it doesn't have a stop like most fittings do.
Right.
So are we looking at, I think
You're
there
looking at
might
the
be a,
straight edge before it curves.
oh, okay,
Can tell I've
Got it.
had that question before.
yeah.
Every manufacturer is different. Some have stops, some don't. Some have flat tops, some have domes. I prefer the domed caps. The flat caps tend to not handle my high pressure test. Anything else? Nicole, Janine, do you two have anything you want to add?
No, I have nothing else to add. If there's no more questions, I do think that would wrap us up for today.
Sorry.
Go ahead. No, this is your.
On the video, you know, he was doing the end of the PVC pipe with glue.
Yeah.
And so no primer is necessary on the end of the pipe.
Honestly, I don't put it on the end of the pipe. I do it where you have the taper, where you beveled it, yes,
Okay.
but I don't do it on the end.
Okay, because I had never seen that done.
Yeah, I don't do that, but he's a colleague of mine. I'm not gonna argue with him.
Okay.
He's about to retire. Any other questions? All right. Linda, how are you? I haven't seen you in a while.
Oh, there she is.
You're muted still, Linda.
There we go.
Yeah, I'm good.
Cool.
Life is good. Thanks
All
for
right.
doing such a great job, Stephen.
No problem. Just want to make sure you're doing good in this pandemic time. Haven't seen you in years.
I know. Take care of yourself. Thank you very much.
You're welcome.
All right. If we have no other questions, I think that wraps up our presentation this afternoon. So thank you guys for joining in for the ASTM Bonders Qualification Certification course. And a big thank you to you, Stephen, for leading this awesome session. Our
No
next
problem.
session is tomorrow, which is Introduction to Backflow. That will begin at 12 p.m. Eastern. As a reminder, that session will have its own separate link to join. Again, thank you, Stephen, and thank you to our sponsors, Rainbird, Hunter, Ewing, and Brightview.
Okay, and just a reminder, if you need this training for your cruise, I can do it via Zoom. Hopefully November I can get back on the road, but I'm also fluent in Spanish, so I can do it in English or Spanish. depending what
Excellent.
part of the country you're in. All right, thank you all.
Thank you guys
Hey,
so much.
Yeah.
Hey, Nicole, can I jump in real quick? I was just going to ask for the people that are going to be doing electrical troubleshooting tomorrow, did you guys receive your packets okay? Everything's okay? We'll kind of go through it again tomorrow, but I was just going to double check and see if everybody had received those.
Yes.
Great. And that hopefully all the wire nuts had stayed together and everything else. Otherwise, we can kind of go through that and make sure everything's connected tomorrow. So cool.
Love to see how you
troubleshooting.
put that together.
Nicole, would I, as a guest, would I have received that? Or-
No, I only sent that out to the educators. Sorry about that.
Awesome. No, you're fine.
Greg, if you want one, I can send you one. I mean, you may not get it by tomorrow, but if you, I've got a couple of extras that if you wanted one, I'd be happy to send one to you then at some point.
Oh, what's in the kit?
It's just kind of, it's a little test. I don't know what it's a little test, kind of a test kit for doing electrical troubleshooting. Yes.
Oh, that's awesome. Yeah, that'd be great. If you don't mind.
So cool. Is that okay, Nicole?
Yep, that's fine.
I guess. Okay,
Thank you.
cool. Rock on.
Great. Thank you, guys.
Thank you. Take care.
Thank you, Stephen.
You're welcome. Bye-bye.